Hello everyone, this is Pragya Srivastava, an educator of Unacademy. Follow me on Unacademy Learning app where you'll find my minimal courses. And this lesson is all about Canal Regulatory Works, where we'll be studying about Canal Fall. Canal Fall, which is actually very important for safe and efficient supply of our irrigation channel. Let's see what we mean by saying canal regulation works. Canal regulation work is actually any structure constructed with a view to regulate the discharge, full supply level or velocity in a canal. It is necessary to provide canal regulation work for efficient working and safety of your irrigation channel. Now, the different types of regulation works are canal fall, head regulator or head sluices, can be a cross regulator, canal scape or canal outlets. All these different structures actually helps in regulation of your water in the canal. Let's study what does we mean by saying a canal fall. Canal fall is an irrigation structure constructed along a canal to lower down its water level and destroy the surplus energy liberated from the falling water, which may otherwise scar the bed and banks of the canal. Whenever the natural ground slope is steeper than the designed bed slope, that means somewhat like this, the difference is adjusted by constructing falls or drops at suitable interval in the canal bed. Why? Because actually what we see that the velocity is going to be directly proportional to slope. So, the velocity increases manifold and will ultimately cover the canal bed if falls or drops are not provided. And in Mughal era, Eastern Yamuna Canal was built. In Eastern Yamuna Canal, they have not used any fall. There was no falls constructed there. Then how could they manage? They aligned the canals on zigzag route in order to increase the length of the canal and dissipate the excess energy held in friction. But later on, they have started providing canal falls instead of that. The different types of canal falls that has been constructed or are being used are ogee falls, rapid falls, stepped falls, notch fall, vertical drop fall, or it can be a glacis type fall. Glacis type falls can be of two types. It can be a straight glacis or a parabolic glacis. Straight glacis is also known as English fall and parabolic glacis fall is also known as Montague fall. Here what you see is a ogee fall. This is your ogee fall where the fall, what you can see that the fall has gradual convex and then concave curves with an aim to provide smooth transition of your water and to reduce the impact here. A hydraulic jump is formed here which dissipates the kinetic energy. This type of fall, ogee fall, is actually constructed on Ganga Canal. Though it is a good one, but it has its own drawback. A considerable drawdown on upstream causes bed erosion And due to smooth transition, kinetic energy gets preserved for a sufficient depth, and the depths gets covered to ensure formation of hydraulic jump. Now come to rapid fall. Let's see what a rapid fall is. In rapid fall, this is your rapid fall. You can see the curtain walls here on the upstream side and downstream side. These are all stone pitch, rubble masonry work. And here is what the hydraulic gradient jump forms, and this is your sloping. Natural sloping glacis is here, and it is normally maintained at a slope of 1:10 to 1:20, but I have given here a slope of 1:15. It lies somewhere between 1:10 to 1:20. This type of fall is actually very good, shows good results, but the cost of construction is actually very high. An improvement here can be seen from rapid fall to stepped fall. Stepped fall, here what they have done, in place of the sloping glacis, they have given it in steps, so that the water does not there is no sharp fall of the water, and the energy gets dissipated on the way. Shows a very good performance, but the same actually the case is here as well. The construction cost is actually very high. Then we can have a vertical drop fall. You can see the picture of a vertical drop fall here. The water is coming here, and then a water cushion is formed, then water is going out. This is your vertical drop wall. Strong pitching is done to protect the bed, and this is your concrete floor. In vertical drop fall, a raised crest falls with a vertical impact, and this type of fall was first of all introduced on Sarda Canal system in UP. So this is also vertical drop fall is also known as Sarda type fall. This fall is simple and economical, and here the nappe impinges in the water cushion below, and there is no clear hydraulic jump that is formed here, and energy dissipation is brought about simply by turbulent diffusion. Though it is a good one, but it is not suitable for discharges which varies over a wide range. Please go through these different types of falls, try to understand it, and see the differences in each of these type of falls. There are some more which we will be discussing in our next lesson. Until meanwhile, you please try to go through this chapter in a very nice way, and please wait for the next lesson where we'll be discussing more on these canal falls. Till meanwhile, keep studying.